Hello, what's up? I'm Junchan, and we're back on stream for some more pure script and Comonads. And last time we were trying to hook up this explore m function or variant of it that we find in the CoFree library. Let's go to CoFree, and here we have explore m. And it seems like that's the type of thing that we want in order to, in order to consume our CoFree comonad of handlers and eliminate monadic values and have some effect with an interpreter that can pattern match on the CoFree and the free constructors, base functors, and be in a base monad M. So, monad rec. I wonder whether there's a monad rec for effect. There is. Okay. Okay. So let's duplicate our log. Let's do our little housekeeping things. We are August 21st. Time flies. And the Comonad stuff. What I noted last time was that we were, that what we were trying to do was to write explore using explore m prime so that we can have the interpreter we want. And to do that, I wanted to try and rewrite some of the combinators, in particular listoff, which is something that came up when I was refactoring and trying to use a different explore that would have the type we want. More specifically, a component type that actually lives in CoFree G, meaning whose comonad W really is a CoFree G. So we're kind of specializing Phil Freeman's work to only CoFree comonads, at least to see where that leads us. And while doing that, we don't have the right type anymore for some of the combinators. And that leads us to having to use, having to try and find the correct type for a listoff that would operate on pattern functors. But before I get there, I think I probably want to try whether I can make things work with the existing combinators and play with that interpreter machinery, because that seems that that's going to be probably easier than trying to do what I'm doing right now, which is pretty fraught. So let's import. Did we use listoff here? Listoff. We did use listoff. So let's use listoff W instead, and that. It doesn't work right away, but that's because React Explorer, right? Because React Explorer at this point takes a component G. So, and we didn't even modify the body here. We only modified the type signature, and it writes. It should work because I've made inner function explore more polymorphic in. Well, no, that's not. I made it more polymorphic in A, and I made it so that it worked for CoFree G comonad. So there's really no reason why this shouldn't be W, right? But maybe I need to check myself here, because I want to use explore m prime, but I'm not so sure, and so therefore I need co3f. So I need some kind of specialized version of the comonad we use and the corresponding monad. But I'm not 100% sure that the way that I'm trying to specialize it here is the way that it should be done. Also, these expanded types, they don't really help me. Maybe they do. I'll need to go back to this, find who's the A here, and yeah, what do we do with sands as well? Yeah, that's not going to be easy. So maybe I did too much refactoring last time. Let's see. So one thing that came to my mind while looking at this was that we could create a React Explorer that would take a component W. We could also, for now, just let go of counters and just work with a counter. That seems to work. So let's see whether we can make that actually run in the browser. Okay. Switch to tab and then move this all the way to the end. We are opening way too many tabs, but that's our style. Okay. And so therefore add counter, yeah, that. So we just have one counter now and it works. Okay, so that should simplify the list of problems we have to deal with right now. So G is the base functor, which in our case is counter. And now let's focus on how can we then find this shape. So it sounds like A is this and B is A. So A is this and B is A. This is sort of natural, right, in X and Y somehow. Okay. It could be that we don't need now the handler to be in effect. That's possible and interesting. Because really we want this to be in effect, but so could that then completely change the shape of this? Because this is the monad we want, the monadic action we want. Do we need it to be in effect unit because of the fact that we use it inside inside the render function here? Pure unit, I think, is the I think I'm going to write the type of handle, which used to be send, right? And it's handler action. And handler action is action to effect unit. And maybe we should just write those things. Handler action, and that means that it's action to effect unit, and that means that it's free counter unit to effect unit. And it could be that we need this because on key up takes a event to effect unit, but we could just do, you know, we could do we could return something, or we don't need to return something, but we could handle the effect. I don't know how, and we could return pure unit, right? And that would be would need to lift that. Yeah, we could just ignore whatever is returned. And I think this could be therefore not in effect, and it would still work, right? Or do we need to use lift effect? Or maybe we just need to use pure. And so handle could just return unit actually, if we wanted. And then we could do just handle blah. And that would work, I think. But then, do we need it to be a CPS thing? That I think we do. Yeah, because it needs to somehow eliminate, which means handle this, and it will eliminate it by doing the send. Because we're comonad that expects that we're comonad of A to B. And not really, right? So could we recapture this shape? And would that be a good thing? Sounds like it to me. Because then X is this, and F is our free comonad, base functor, and free is full of these things. Oh, that's interesting. Yeah. Here, Coco free G sort of is like free G. So is that even correct here? When we run explore and prime, if we do this in handler, which I suppose is where we're heading, yeah, except that we're going to need to be in some MA here, right? So we are not going to be able to use React Explorer exactly in the same way that we were using it before here. We take a React class. So we'll need to make this monadic, and maybe that's okay. It probably is. So render takes a container and page, the element, will need to be also passed monadically. So I suppose here maybe we'll do something like do C will be the container, and P will be the page, and we'll render PC, I think. Yeah. And we'll need to say that this is do and return pure here, and then we'll need to say counter will be React Explorer counter, and list will be React Explorer list. And okay, so we're now saying that this returns a M A, and for now we'll just say it's Explorer. It's in it's the we will fix the base monad to make things simpler, and I think that means we need to say pure here, and here yeah. So render I think we could actually, I think render is actually in effect also. Let's see, how's that work? React Basic. Pure. Okay. component that might be in React, PureScript React itself. Indeed it is. And it takes the component spec and render is effect React element, yeah. So we could actually avoid being in effect here, and we could still deal with effects going on in Explore. We just need to well, okay, well, I'm not sure I like that, but that means that we wouldn't have to do the refactoring that I just did here, so maybe that's better. And that just means that it's out of here. That would do something like oh, actually, shouldn't we just how'd that work? Yeah, no, that's it, I think. That's it. But of course, here for now, let's use the same type and see whether we can make it work. Go free G of this thing, I believe. And then we say pure here. And no pure here. And seems like it works. Okay, and then I'm saying we remove the effect unit here. Let's try. Okay. No, we can here, I think. Yeah, I think so. Hold on. This takes an S. The second function is right, which takes this, right, this is just component, this thing. It's actually component G, isn't it? Maybe not. Maybe not, because we are in A. So it's component W of cofree G. Hold on. Oh, did we let go of being polymorphic in the return type here? We didn't, but that's why I actually unrolled this whole thing. Yes. Okay. So now we just need to say unit here and see whether that works. I mean, we're going to need to rewrite handlers and handler here. Not going to be the right type for us. Too many refactorings in parallel, I think. Shred state handler. Handler getting the M. That's the M. Unit with effect unit. Explore. Text go through G, blah 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 to effect unit. Oh, go for G unit 2. So how come this hasn't percolated? The handler type UI. Let's remove Spago folder and the output folder, and rerun Spago build. Oh, okay. I'm going to be right back. Get some water. Okay, unit with effect unit. So same error, and the type of explorer, if you can master it. Maybe you can't because you can't compile. That would make sense. Yeah, so I was trying to return in effect A. So if I do this, that doesn't work. Let's revert back to something that works for now. Right. Because of this. Yes. So, yeah, I believe it's maybe because of the type. Yeah, let's see. When we extract state send, we to UI codable unit we pass handler codable unit, and since UI codable unit is the handler codable unit to React element, when we pass it the handler, then we get the React element. But the handler we pass now we still want to be handler as well, but handler action. we want this to be cofree G, and then here the type doesn't match. Apply red blau. Cocoa free unit. So let's expand this. Handler should really be cocoa free unit to unit, right? Right. And right doesn't have the right type for that. So let's write that way, and then we need to be pure here, and then this needs to run in effect, and so that doesn't work. Okay, so I think handler it's about right. We want right to be in effect unit, which allows right to actually trigger some side effects. But then we need to do this. Right in effect unit. We extract I mean, this starts to be where ideally we have our explore M prime that starts to do things for us, but maybe right waits for a component and extract. So run co m extend constate is one of those guys. So if this was the type of handler, that wouldn't work, because we'd be basically returning a cofree G unit, I think here, or maybe one of those crazy guys. And then how would I pass it to right? I mean, I would just pass it to right and that's it. No. Does runco return a unit? Let's double check that we have the right type here. I think we have the type of maybe this. Or maybe just this. But runco is going to return an R. How does this work? Runco turns an R. Runco of M, but runco being passed an M, which is a code WA. Or you're saying, yeah, that's the second argument, is the W of A to R. I think it actually is this form. Is it? No. So it returns this. Okay, I am pretty lost here. Right is going to take the comonad that we provide as an output and is going to just return effect unit. But we also want to return effect A. So that's the result, and maybe we write the result, but then we also return the result. And we want the result to be of type. Oh, no, that doesn't work. That doesn't work. Also, this doesn't feel as generic as I want it to be, meaning trying to not tie this too much to React. This write function seems like it's still very much tied to it. The A that we return here, in truth, is the React element. And we go through these hoops in order to say that it could be something else. And I think we should stop going through these hoops, and at least temporarily, and say, because we already doing something a bit weird with the base functor here. So I think we could say here that we mean component G, which means that it's in React, and here we say that's component G to effect unit, and then here is effect of our React element. Which means that result really is our React element. That's what we want. And then handler is going to be a bit easier. Well, yeah, a little bit easier in that I think we return component G here. Okay. But basically, handler doesn't have the right shape to be passed to extract, because the extract state is going to return component G, which is a comonad full of the handler. And we are not passing the right thing. So the right thing is of type unit, but then this is not the right type. It feels like this is where we want to reach out for explore M, but I mean, but what this sounds like, that's exactly when we should reach out to explore M. Yeah, but we want the next step of the co-free comonad, and explore M doesn't give us that. Which is one of the reasons why this whole run co m extend const state is the right shape, because that particular shape is the shape that returns a component. So does this mean that there is another that there's something else there that is not explore M, that looks like unfold co-free? No, that maybe looks like host co-free, maybe. Co-free of F to co-free of G. No. It's more about actually executing the co-free, right? Let's take a look at the source code for explore M. It uses run state. Which I think build co-free uses as well. Map co-free. Defer. the tuple. It doesn't apparently, but of course it k is the state modifying function, or is what takes an s and gives back the state and gives back the next co-free. Maybe I want to expand runco, and maybe I even want to expand extend const, because state is really it's a comonad of handlers. Yeah, we don't want to write the result. You know what? There's probably a combinator. I feel there's a combinator for this. Yeah, but not like that. Not like that. Okay, let's try and decompose this for a second. When we pass it right, we return effect unit. So that sort of goes into the ether. We don't really care about the return value. But it was mighty convenient to have effect unit here. Ah, right. We don't care about the effect because there's a kind of a wormhole effect there. Like the component G that we pass into this effect unit actually populates the sort of the persisted component. So the React element that we get is the one that's sort of full of handlers waiting for the next monadic action to come in. This inversion of control are really hurting my brain. We extract state and we pass this handler. Which in theory, we now don't want to have side effects because we've removed the effect here. But in practice, actually can have side effects because it returns in our React element. So what? And plus we return in effect, which is strange, but allows us to think about a base monad, I believe. At least maybe try to get closer to that shape, but not so sure anymore. This is going to work for us. Particularly because of the fact that this shape of sending the state, writing the state elsewhere, and then depending on React to call us back is strange. We use state twice here. We extract the current state, pass it the handler, which makes a W that was waiting for an A move forward in time. That A is units, isn't it? But once we have it, we get R, and R is a component G. Which we write. Okay, and how about if we say that we make the handler effect full? Somehow we manage to pass handler to extract state like that. Handler would be an effect unit, and we would pass it to something that I suppose we could make pure. Why isn't that the right? Oh, right. Is that? No. It's a problem because of the return type. Now, the moment where we pass handler, we are now in effect, right? But handler is actually a to MA. Oh, hold on. Am I doing it the right way? Just extract state. Boom. And maybe it's the other way around. Maybe not. Could not match React element. Extract state. So handler is some A to MA. No, but that doesn't work, does it? Extract state unwraps the component into UI CoW unit, which is handler CoW unit to React element. Okay, let's write this down again. So what I want It feels like I want something like sequence or distribute again. What we have really is an A to MB, and we want to return an MC. It sounds like that's something well known. A to MB, and we want to return an MC. Is that? That's just the the lifting of extract state. So it's pure extract state applied to handler. No. Yeah, no, that's no. It's a bit more complicated than that. Yeah, because our Comonad is full of these things. And so when instead of an A to B, we pass it an A to MB, it's just not happy. So it does sound like we could do it in 2 phases, maybe. Where the problem that we can't. Oh no, maybe we hold on. Let's try again. I think I went down the path before. So to return our React element in an effect, I think we can just do pure extract state next. And then we just want to write next. And we don't need a handler. Except that we do. And maybe that's fine, but probably not. So let's think for a second here. Is it just because we'll do this? No. So next, I mean, I don't know why I call it next, to be honest. Let's call it handler. And handler right now is of type, yeah, he's of type something we don't want. We want to write, but inside the comonad is what really it's about. Whereas here I'd like to write outside the comonad. So maybe we just say that state is extra state handler. That's the, is that what we want to write? And then we return S. I don't know. Sounds like that's strange. Yeah, I think we would need to write it in pure actually. And handler. Okay, the type of this doesn't come from that. What is the type of handler here? Is that, is this, right? But then what's the deal with that? Takes the M and oh, yeah, again it doesn't work. The write that we want to do still get the intuition that it happens inside the Comonadic CPS handling thing. Extract state. Extra state waits for handler, returns a React element. And this we want this to return unit. Instead it returns this crazy thing. But if it returns unit, then nothing gets executed when we call back from the DOM. Whereas what we'd like is for write to be executed when we call back, when we call from the DOM. So apparently it needs to happen inside here. It can't happen inside here. That sort of doesn't make sense to me. The handler gets called. And the handler cannot have an effect. I suppose it makes sense. So is that then where I reach for my explore? Let's try. So what would that even look like? We need some explore m prime, which we don't have, but we can write it. Explore m is this, and explore m prime would require to shift this to co-free, this to free, and that's it, right? This is yeah, okay, because I did some shifts here, but maybe we mean this, right? I think. Oh, you know what? Maybe this. No, I'm still a little bit fuzzy about what this means, especially if we squeeze this in the A. It looks like, yeah, it looks weird. But let's just reverse our W and our M. Our co-free is it? Yeah, no, that's not gonna work like just like so, because if it's a co-free comonad that is full of functions, then we're going to need to change a whole bunch of stuff. But I don't think there's a way around it. But it means I'm going to go into another rabbit hole that is going to be quite difficult. Not sure about whether I can even apply the results to this. And the main reason I'm a bit skeptical is because of the fact that our co-free F is actually full of it's full of monadic actions, because that's how the whole things try to get by, right? Because of that send m idiom, because of that handler m thing in here, that ultimately we're full of Coco3G units inside. But But do we need that? If instead we can just grab the cocoa-free G here, so not do that then. Because this is the co-free G right here. Full of A's, if we want it to be. And so I mean that means that our components are something completely different in that case, right? In that case, do they just hold React elements and that's it? Might be the case. Okay. It sounds like it leads to a completely different style. But I think that's correct, right? Well, no, it's not exactly correct. It could be, we could say that it's full of, let's say, unit to our React elements. If we say that our A is unit, we could try that for a start. Okay, so something completely different. Component G is component is co-free G of unit to r dot React element. And therefore, component W is just the old thing, and so our co-free still we're waiting for something in order to display itself. And what would that mean for React Explorer? It would mean that we get the state space, and when we explore with the state, we take a component G, we know how to write it, and we will try somehow to, this will return an MB, so we specialize to effect. Yeah, no, if it's not full of a handler, then in that sort of double CPS way, then we haven't inverted control enough, I don't think. Explore M. I mean, what's more is that I think I'm saying that we need this again, which is exactly what component was before. One thing that comes to my mind is that the reason why we need this double inversion of control is to be able to use this idiom of passing this handler inside a DOM callback. But it feels like if we had some kind of adapter, which is a little bit what I was trying to think about last time, which means that we would have some kind of adapter, then maybe that's the low-level wrapper for the React component in order to capture the inputs. But then maybe after that, our API somehow doesn't need to refer to this anymore and can see the stream of actions just as a stream of actions, which would then allow us to use something like this, where I'm not even sure about the Explore M idiom, because the fact that this also uses state It's just a tiny bit puzzling, actually. One of the questions is, where is the loop? Because explore seems to keep track of state. Let's look at the source code for explore, not just explore M. This is run free M. It also uses the state monad. It creates a state monad that takes current state, which is the co-free, and then pairs. It creates a pair of. Oh no, pair is the pairing. Yeah, pair is the pairing function. So it pairs. It pairs the rest. Hold on. It maps tuple ff being. Oof, okay. This is not easy. Okay. Run state, run free M, step M. W. And then it maps tuple f cof on the result of that, and extracts the latest value from the comonad. And applies f to it. I want to play with that. Don't I have a pure script? I think I have some basic comonad code that I could use to test this out. It must be script comonad playground. I think I'm going to move that to experiments and call it comonad playground. And okay, well, let's sudo this and cd this and check it out. And can we spell go build? We can't. Because of pairing Coty. Pairing Coty function with co-free. Interact. Okay, let's try and build. Okay, and run, or maybe test. test RMT, but we do have a main. We should probably move that into test.main, no? Ah, well, that's fine. Okay, so I wanted to try explore here. We do have a couple of comonads. We have a store comonad. Don't know if I want to play with that. We're going to need some. We have stack. Let's go free maybe. And is there? I don't think there is a pair to maybe though. I think we've tried to do that before, haven't we? Pairing. Tuple function. Yeah, I think we did try to. Yeah, we can't pair maybe. Can we pair Kofri maybe? Oh, no way. Why could we? Because if we can't pair maybe, I mean, oh, so that's where I started saying that maybe these things with type level naturals could be maybe paired. Right. But let's take something standard here. What is standard? I think it's like list and nuts, isn't it? Free identity A. Pairing nat with stream A means picking the nth element of the stream. Oh, so Kofri maybe A pairs with nat? No, because Kofri maybe A is not a stream. So what am I saying here? Kofri identity A maps with free identity A, which is not. I think that's the thing I mean. Not with stream A, co-free identity A, and free identity A is yes. So shall we try that? I mean, we run into this issue about infinite containers, but right. So how do we stop here? Yeah, that's not gonna work. Free and co-free. I'm gonna F pair with G. The tuple function one is just not very nice, but I suppose we could just do the product coproduct one, but free of product and co-free of coproduct and vice versa is a little bit hairy, right? I mean, one is a list. Right, I think free of product, well, product what is one of the questions. Actually, that's, yeah, it's like free of tuple is of tuple A is a list of A, isn't it? And co-free of a function from A is some kind of function that well, that seems to be waiting for like a huge amount of arguments. Let's try. That's the co-free function from A and B is a B with a function of A to co-free B. Is that right? No, it's definitely yeah, no, it is right. Okay. Let's try this. Maybe this will work. Trying to find a good functor pairing to have a good co-free free pairing to test Explorer and Exploram. So let's try this. Do we do type synonym? Will this work? No, of course it won't. We need to say myf it's not exactly list of A here, right? Since it's isomorphic to to pure B or free tuple A and free F B. So it's a list of B. Oh yeah, it's a list of A's with some carrier B, which we can sort of ignore if we want, or yeah, no, because it's only the last element that has a B in it. So it's a list of A together with some B. So kind of a tuple of list of A and 1B. And my cofree thingy is that, which is sort of a B or a function from A to a list of function from A to yeah, it's not exactly that, right? It's yeah, a list of functions from A to my C, I suppose. Something like that. It's not very clear. It might be tough to build some of those, so let's try a myF of type myF unit, and we can put units in pure, and then pass that into. I think we can't use the constructors, but we'll try it nonetheless, and do like put a 1 and a tuple and a 0 and a pure unit. Except I don't think we can build things like that, because we need to build them differently. So let's go check out how we build them. We don't wrap them. Yeah, we can't really build them like that. So how do we build them already? Lift F. Unwraps. How do we build free things? None of these things are exported. All of these things deconstruct, except for subs free, which is kind of like a hoist, and lift F. So that gives us this at least. And will that work? We can't use pure. Yeah, almost that, but so it's wrap actually. It's not if stuff. But how do we wrap the empty thing? How do we generate pure? Oh, is there... Does the monad instance give us what we want? From view return. Okay. Wrap pure. Right. Function. Okay, let's try the simplest by f. If we say pure. Yeah, maybe we say pure unit. Oh yeah, that does work. Okay, so pure unit. We use the monadic interface for that. But isn't there like a monoid as well? Can we use... there isn't a monoid. Oh, there is a monoid. So is the monoid... is memty also... Memty is pure memty. Given that A is a monoid. Okay, so that's a different thing. And what's up? Maybe just pure unit and that's it. Yes. Okay. We've got something isomorphic to 1, 0. Now let's try a Comonad equivalent, and go to Cofree, and I should be able to just build it there. So if we say our B is unit, so we can just add B in there, and then we have a function from some I to to another Cofree. Okay. Doesn't say that we can do anything with that I. just know it's an int. So we just grab it, but maybe this is part of what explore will help us do. Maybe my C is just a structure. My F has some, yeah, although we are going to have a problem here with the type of explore and explore M, since they take a functor full of functions, and right now we have a functor full of ends, but we can figure that out. We can totally figure that out. Okay. That's our pairing. That's our free functor, arco free functor, and the return value. Okay. So here we're saying we just wrap how does this work? Blah and another J. Hold on. That doesn't work, right? Because I would need to stop at some point. Or could I stop with the identity function? I suppose maybe I can. So let's try that. And let's get this constructor. It's supposed to exist, but it doesn't work like so. Because we have a function from a thing to let's take a look at this. Yeah, that's not the best thing to look at, to be honest. Stack is probably best. Ah, yeah, right, okay. So we do need a unit at the head of things. And then maybe we need to somehow make a co-free out of this, or what? Ah, yeah, identity is not going to cut it. Because we need to lift that somehow. Well, we can maybe write one that would take an I and return unit and function from I to ID. Oh yes, just ID actually. Okay. So that's a bit weird, and also we could just have ID here, I think, meaning we could have my C here. Or not exactly, yeah, like so. Okay, so we're putting a lot of hopes inside the explore function, but I'll do this in a sec. I'll be right back. Okay, so let's try and whip up an explore function now. So we'll try and lock something. Maybe we'll well, what we want is to create that interpreter. So interp is going to be a for expect of myf, and we're going to need to do a myf full of functions from into something, probably into string, and yeah, it will be myf of show. Yeah, we could do show and append some. So yeah, so let's call it myf show is going to be a function from into string, and that's going to be doing like taking an I and returning show of I plus, well, let's say show of I plus concatenated with show of 1. How about that? Yeah, I think that's possible. And then here we could say wrap a tuple of that same thing, but with 0 in there. And then we have too many parents. And That sounds good. So interp is going to be equals to, so, oh, we need it to be for all x and y, so that's the thing. And that should be fine, I suppose, because we could just hopefully find something that works here. And then we'll explore interp myf show myc, and that should return us a b, which should be a string, but that's only true if we can pattern match here. Yeah, not with the myf. Oh yeah, with the myf. No, not with the myf, with a tuple. That's the thing. Like here we just need to map a tuple, and here we just need to map a function from x. Is that gonna work? The function from x, oof, that might not work. I'd like a function 2x. Hold on, a tuple of what exactly here? Am I? Yeah, I'm doing it the right way, I think, but so now we have an f. So it's a tuple of a and a function. So maybe not exactly that. So maybe we fix our a actually. Ah, yeah, we do. Okay, that's good. We fix our a and we have an x here. That's better. So that's a function from a to an x. And we just happen to have an a here. So so here we can pattern match on an a and an f and a g, and we can just give the g to the a and apply then the f. I believe that's the idea here, and we just need to import explore from control co-free, control Comonadic co-free. And then yeah, that's that. Oh, I don't know what I did here. Just this thing needs to be put back at the end. And that variable a is undefined. Right. Yeah, we could say for all a. That's fine. And then G doesn't have the right type. G takes an a. Well, do we need to? Yeah, we probably need to do that. And then, oh, we need to map unit with T1, T2. Okay. So hold on, myf a or b. Oh, right, hold on. Okay, so indeed, that's not right. We want to co-free a function from int. What is it? Okay, I'm lost. Here we have this. Therefore, we have free of tuple A of A to B that's going to be problematic. But fine, let's leave it for now, and let's just say that that's my f of A and A to B. That's going to be confusing. Okay, let's call this guy something else. Let's call it T, and let's call this guy U. And then let's call this guy A, because that's the better. In fact, usually this guy is called R, I think. Let's call it R. And then let's call it R here, and my F R A to B. And let's say that it's an R here, and that sounds good. And call it R and be happy. Okay, and so that's my F R A to B, and therefore this is co-free function from R of A, which is my C R A. Indeed it is. And now that we want B to be a string, then what we need is not my F show. What we need is something completely different. We need carrier type that means something. So so I'm gonna keep those just for giggles. And write some that means something for what we want. We want my F to be my F of, let's say what? R. So we don't really care about what the R is, do we? Okay, so int, and let's say unit to string. How about that? And then my C can be my C of int as well, because that needs to pair. And unit. So my C can be some C. But, come on. But my F needs to be something like wrap tuple 1. Yeah, okay. The unit to string is going to be the end thing. Interesting. So pure of a function from unit to high. Okay. So now if we say my F here, it compiles. And now we can spago run. and it says hi, which is fine, right? But now we can probably go to try and do explore M, because the idea here, I suppose, well, we could try a co-free of a B. We could try to write an explore prime. That might give us a little bit of training, but is that really satisfying? Or should we, for instance, by the way, the interp is really the pair, but do we want to maybe do the symmetric of it? And is that going to be more interesting? I mean, right now, yeah, it might. I'm not sure it will, because the fact that maybe it is because of this unit. So let's say that we have a well, let's do it here. Let's put an int here, and let's put a unit here. And a unit here. And then say 0. And some f. And what's going to be the f? It's going to be something from unit to my C unit int. Is that right? So we can ignore the unit. But we could pass it an int. And we could then pass it the f with the I plus 1. And I think that gives us incrementing list, maybe. Yeah, we need to do probably 0 f 1. Yeah. And then we need to go from int to string. Then we could say, give me the high, but also give me the result. And then we can run that. And we have high 2. So we know that, so this thing is a kind of a counter. And then this is the, I'm starting to realize something. Something is dawning on me. That's quite important. So that's kind of a counter, and then this allows us somehow to we're counting, and then at the end we're able to also provide the resulting value. So this makes me think a bit of Kenneth Foner's talk, where what is it, Loeb's theorem, and basically things that refers to themselves. So that's a structure that contains 2 units, and then the number of units actually going to be passed to it, such that it can show the number of units. But the thing that I'm realizing here is that in this case, the comonad is very much determining the sort of the operation, and the interpreter really is not an interpreter at all. You could say the comonad is the interpreter here. The interpreter really is just the pairing function, and we could even maybe use pair here if we had the type class figured out. Do we have the type? We don't have the type class figured out, but I think I could copy paste the work from pure pairing here, and maybe that will work. If we also have data functor pairing data functor pairing should give us pair okay. Yeah, give me pair and sure, leaves and over as well, and this should make this compile. Yes. And so now I should be able, by importing the data functor pairing class, which is not here, import data functor pairing class and pair, then I should be able to not even use pair here. Except it's the other thing. So we need zap. Yeah, we need zap. I think, and at least this maybe the symmetric of it. And zap and zap. Seems to work. Yes. So in truth, explore could also be rewritten such that actually it just takes the pair. And what's going on here is that this is highly constrained because it's a full XY, and that means that basically there's really only one guy for that. But it means that we can rewrite explore, and I'm going to want to do that. Where is explore coming from? From control command co-free. So let's rewrite explore. It's going to be nothing very original. Can keep that type there. Yeah. Oh wow, actually, yeah, that's good. And well. Okay, yeah, let's do it like so, and we say here this is pairing FG. And then we need to say this is a constraint, and now we don't need pair here because we derive it as long as we import class pairing from here. And we need the state monad as well. And pair, what's up? Unknown value pair. Ah, yeah. Maybe it's zap actually. Maybe it is a zap. Yeah, and then we don't need this anymore. And that looks like it compiles. So we have a pairing type class version of Explore here. And that's okay, but I want to try a couple of things. One thing is to have the co-free be the A to B. So let's try that right away and call this Explore Prime and have this. And therefore we'll want something fairly different here. Yeah, so that's going to be of A to B, and that's going to be of A. And so we are going to need to just be a little bit OCD, and we're going to want to call this prime, right? Of A to B, and that's going to be my F prime. And then the code's going to need to be different. So let's save and see what we need to do. So first of all, this is now WNM. So that's big change. And then our types online. So we're trying to run free M. Let's get the type of that thing, because I'm not familiar with it. Run free M takes a functor F, a monad M, some wrapped free functor. Oh no, some function from a wrapped functor to a monad, a free F and an MA. Okay. And step is in state, so it allows us to have this M that we can then just run so that we can return it later. So at each step, which takes the F from the free. So the thing is that we're going to need the equivalent well, so yeah, the thing is that our M doesn't have a function in it anymore. So So the type of that's going to need to change in any case. And so instead, I think instead of accumulating, we're probably going to need to swap things here and hope that there's an equivalent for run free m for comonads. Let's for co-free comonads. Let's see whether there is. I'm wondering whether it's unfold co-free. Probably not, right? Because this return thing in MA. So that feels a lot like it's running the whole free there. Like it's actually like run free m actually has is a recursive thing. Let's run free m. Runs a free monad with a function that unwraps a single layer of the function f at a time. It's a recursive monad, but run free calls go, which calls go. So it is recursive, and it basically runs free kind of purely. Run free m runs free with what arguably is an interpreter right there. So step is our interpreter, but yeah, what's going to, so that actually the equivalent of that is explore itself. Why don't we have something that that feels more like that in co-free? Why can't we just kind of unroll a co-free? Is it because it's an infinite structure? Is it always an infinite structure? It is always an infinite structure. But that shouldn't be a problem if we're, especially because we know that the co-free in pure scripts is lazy. So if we want to loop until infinity, then nothing should prevent us to do that. Okay, so what I'm saying is that maybe there's a run co-free m and instead of this interpreter, well, I mean, that kind of makes sense, right? I don't know if we're going to be able to write it, but it's to say that we defer the co-free, or do we need to tuple blah? Maybe we need to tuple blah here. No, maybe not tuple blah, but maybe we do. Maybe we need to have a tuple with an A here. A tuple with an A and the co-free FA. Not sure, not sure. Right, a tuple with an A and an F go free FA. That maybe makes sense. Because at each step we do receive an A, right? We do. And then a continuation. Okay. So let's try and write that. Run go free M. Let's also go check out Haskell there, because it might just be that it exists in the Haskell ecosystem. Doesn't. So the likelihood that therefore I'm stumbling into a thing that doesn't exist is pretty low. But the likelihood that I will learn something out of following that rabbit hole is high. So let's follow it. Tuple of A and FB, a function from that clearly constructs things. And whereas here we're trying to deconstruct it, returning the next value. Yeah, let's try. So run free M. Let's actually look at that code again. Run free M is this. If we need the recursive thingy. Yeah, no reason not to start like that. And so go will take a co-free Derek needs to return step, which makes sense. And I think we'll never return done, which is just how things are. And go okay, we need to have the type of telrec M. Takes an A to M step AB. And in our case, what does this mean? It means an A to M step, and A is, so it was free FA in the other thing, and that's why we had free FA here, and it has free FA here, and the B is just A apparently, which is fine and sounds right. So step free FA A. Yes. Okay, but then what happens to that guy? Gets passed go, gets passed to blah, but then I'm not sure I understand. Okay. it's a continuation of sorts. And yeah, that's fine. And so now what are we doing? We do take a co-free FA because that's the thing that's going to be passed. And then we can return an M step, but it will need to return a co-free FA. And that's where now passing this thing in M is going to be what it's about. And instead of doing to view of F, which is in the free thingy, to view, it's not actually. Okay. What? To view, hold on. Okay, I see. That's it's not exposed, which is not nice because we're absolutely going to need that thing. And we're not going to be able to. So, well, okay, hold on. We're in co-free though. And in co-free, we can unwrap things without too much work, I think. So let's try. It's a C. And can we pattern match on our C or what? We can do head and tail. And usually we know we have a tail. And the head so we know we're never done. We're probably never done. We're never done. And we apply K to a tuple of head C and tail C. Okay, yeah, that's because we're a bit wonky here and we need to import Comonadic and some constructors from Comonadic class, yes, and loop similarly from Comonadic class as well. Yep. And Telric M as well. And what's up with our types? So Telric M go, return an M of step blah. Go F. Here of I, F map to G. Okay, so there is something here that we're not doing. What's in bind in the let's go check out free again. I mean, that's going to be in the code, right? Free view returns bind that has the current value. Let's take a look at our free thing. Or some continuation. So, but that's that I think is a trick to make this performant. I think it's like this maybe this codensity trick right here. I think, which is like CPSing. So not too easy for us to see what to do here, but maybe we can work it out. So telrec, we want to take a free f. Oh, hold on. Yeah, no, telrec, we want to take a co-free FA to an M step co-free FA to co-free FA. And so that's our co-free FA. And apparently if we use K on it, I apply to G in free view will get us the free FA. And here, if we apply K to tuple A, is it, oh, is it F co-free FA? Hold on. Yeah, F co-free FA. And head is just an A. So then that should return us an M co-free FA, and we should have the type we want. What's the dealio? To MB. Oh yeah. We might need a tab annotation because we never output a done. That might be it. No, though, because we have. Oh, be right back. Okay. So let's just try and solve this and then call it a Saturday. Right, so the possibility here is that, okay, maybe I'm actually not parenthesizing this correctly. That's what it was. So, okay, therefore, let's try explore prime. Just see whether we can make sense of this or not. Explore prime using run cofree m now and a step of w, and then we're saying we run the state with m, but that means our step is going to be, I believe, something like so. And so now instead of so we're taking a cough, and I don't know if we're going to be able to map top cough. Is that the yeah, I'm not sure what the tuple of explore does here. Maybe it's just yeah, it's what the state function expects. So let's write this down for us here. Because the s is free now, so we say ff, and so we're returning ff, and taking an s and returning a tuple of a and an s. So a being cofree f a to b now. So how does that work? Also at the end here we have this, I believe. Yes. And so we're pairing, but we take the state has a free functor in it, and we return something that is going to be what. If we want to continue advancing, then we need to unwrap the free monad, I believe, right? Which is also called wrap, or it's not. Resume. Yes. Is that right? S is the state that's threaded. Which in our case is a free functor. which kind of sounds weird. How about this instead? Right, so step would be the wrong type, but it maybe works, possibly. Let's try. So now we need, yeah, we need some other f's, and we call them prime. And we say that it's the comonad now that has an int string in it, and the monad has just an int. And so if it just has an int, then we can just pass it like 0, for instance. And here, however, if we have an int to string, then this is already a thing. So let's call it G. And let's say that we have a G that takes an int and returns a function from into string. It takes the I and then it returns a function from J to, let's say, show J and show I. And then we'll need to f a g of 1, and we can remove that type annotation. Yeah, because of the I+1 here. Okay, so I suppose I can inline the G here. Okay, looks like maybe I can't. So let's write the type of this properly. So ideally we take a into string. So in that case, we G1, and then we return this. And the way we do that is by maybe composing. No, we take the function from into string. Yeah, composing, yeah. And so that's a G. And we just apply it, and that's it. Okay, so that's a weird one. but I'm going to need to train myself to do this because I'm going to want to have a handler here, or like this double thing. Hey, Actions, yes, thanks a lot for the follow. You're catching me on the tail end of this stream. I've been trying to invent new functions to pair co-free and free monads and comonads, and my dinner is awaiting in the other room, so I'm really close to wrapping up. Let's see. So I'm trying to test my explore prime function, which takes a co-free comonad with a function in it, and I'm trying to apply that to this example, my C prime, which will hold a into string function in it, but I'm having trouble doing that properly. And I think it's because I shouldn't pass this, I should pass this. And then it's an int that's being passed, and yeah, then it's an I. And then the G, okay, then what's up with that? G, yeah, no, that should be good, right? G takes an int, I plus 1 is an int, and then that returns therefore an into string, so that's an into string, and we pass our into string to F. But F takes an int. That's the deal. And so I suppose if I do this, that doesn't work either. So do I need to wrap G here? No. Yeah, I don't think there's another option than to pass into string here. And I think I can use G just to initialize, but then this should be H. And then I should just pass H, but in that case I'm not incrementing every time. But you know what, I can't. That's the thing though, I think. Because there's no way to thread this in the way that I want, so it's just not possible by construction, I think. If I had an into string, okay, I need to have my little example of what co-free is, and maybe also this, so that I can understand what I'm doing. That's the example. Tuple of an A. And that's my A. Hold on, my C means what? My C is this guy. So when I apply it like so, it's a unit here, and it's a into string here, which means int string here. And that means that I have an into string here. Free FA. Yes. So that's right. So that's my into string, right? G0 is an into string. And then I wrap it with a function from unit, which is this. Function from unit. And okay, fine. Let's write G differently, or maybe F differently. Let's have F take an int, which is going to be I, and then let's pass it to this, and then the G can just be the initial G, or even how about the next G? Oh my god, this is a little bit ugly, but is that gonna work? Nope. H is a function of into string, that's right. Unit, that's fine. And then so show that guy here. H is yeah, whatever I passed. Okay, fine. This is going to be a bit ugly, but let's do it like so. Because then I can just do hi and then hi plus 1. But that doesn't work. How come? Oh, of course, fi. Still not. Can't match string with into string. Oh, okay, right. So just H, and so maybe I plus 1 here. Yes. Okay. And it compiles. And so let's try explore prime. And types don't align. How so? Because we have inverted them. And it compiles. And it shows 0, 2. And I don't know what that means, but it works, and so we'll next time we'll just dig a little bit into this and try and move it around and understand what we have. I think what we have really here is that we're only using the last value. I mean, maybe we have the 2 iteration, that's the 2 here, and the 0, that's the first 0. I don't know. Let's see if I have 10 here. Do I have 10 too? I do. And then if I add a, or if I had a wrap, tuple unit wrap, do we have 10.3? We do. Okay. So, I mean, nothing particularly extraordinary, right? But that, I suppose, is some kind of interpreter, and it's in a shape that's a little bit closer to what we want. So if I go to my log, then I should be able to say that, well, that we've written explore prime, which takes co-free A to B. And so we are close to doing explore M prime. Which we'll do next time, but we'll play a little bit more with this and see whether we can have some a little bit more meaning here. Clearly, I mean, remember, this is only a list, right? My f prime is isomorphic to a list with some kind of b. So when we interpret it, we're just interpreting length and the b that's in there, length and the b that's in there. So that's because we interpret, and I mean, this is ugly. We can probably improve that, but that's because we interpret unit here as I+1 in the kind of as the kind of running counter, right? That's a stateful thing that explore prime uses with run state. So I'm not sure. I mean, clearly this needs to be rewritten. I'm sure we can find a prettier way to write this. In fact, it might just be just an unfold co-free or something like that. That lives in here, like unfold co-free probably, or build co-free. That should be a much better way to build our co-free. But yeah, so my C prime, I'm going to write this down here. Or maybe, whoopsie. Okay, I did it again. Here, write my C prime with build co-free. And makes sense of the free co-free pairing in terms of action and interpretation, because it looks like maybe I've been on a wild goose chase with what we were doing right here, with this idea that we would have a free monad with actions, a co-free comonad with our component and an interpreter. And that might be wrong. But we're not sure yet. So we'll explore this, and I think I've captured that with this note. Makes sense of the free co-free pairing in terms of action interpretation. I think that that captures it. So thanks a lot for watching. See you on Tuesday probably, and maybe I'll stream tomorrow. I'll see how I feel. And thanks a lot for watching, and see you later. Bye-bye.